Hey guys, this is Ron. So we're going to talk about lists. So lists are basically a data type that can contain other data types. So I'm going to build a list with my square brackets, and then inside of my square brackets I can list a number of other items. And those items don't all have to be the same data type. So here I did an A. There are 5 elements in my list, and we're definitely talking about a list. And when I look, I've got integers and I've got strings. But a list doesn't care. It's just you're adding elements to this list. So if I look and I do a dir on A, what I'll find is that, again, I'm talking about a list object. So this object already has some attributes and it already has some methods. So I can use append, count, extend, index, insert, pop, remove, reverse, and sort. So I'll try not to hit every single one of these because I think you need to spend some time kind of looking through some of the documentation to see what these various items do, but we'll hit a few. So if I do an a.append, I can append items to my list. So now when I look at A, on the back end side, I now have the number 5, whereas before it stopped at the string 5. Okay? I can count and see how many times an element or a certain value exists within my list, and the number 5 only exists one time within my list. So pretty easy. Extend will look up. So L dot or A dot, let's see, extend. And here, notice it's looking for an iterable, and it's going to extend its list by appending the elements from the iterable. So what is an iterable? Well, it is what it sounds like. An iterable is something you can iterate over. So when we start looking at for loops, what we'll find is there's certain data types that allow us to perform things on every element within that object. And so an array list is an iterable. So if I do an a dot extend, I can send in another list, right? And in this list I can have, let's say, 10, 20, 30. And so when I look at A again, I get all of my things extended by the list that I passed it. Okay, so we've got index and insert. Insert is exactly like it sounds. You're going to insert something into one of these values. So what is that? What do you kind of think you're going to need in order to do that? One, you're going to need the value that you want to put in there. But most importantly, you need to know where you're going to put it. And in order to know that, you need to understand index values. Right? So remember, we had index 0, 1, 2, 3, 4. So if I want to insert something here, I got to do an a.insert. I got to give it an index value, so index value of 4, and I'm going to pass it what I want it to be. So now when I look at here, I go 0, 1, 2, 3, and I've got 4. So pretty cool. Index is basically going to look for a value and return to me the index. So if I did an index of, say, 10, it would say, oh, I found that, and it's 0, 1, 2, 3, 4, 5, 6, 7. So let's try it. So a.index, I'm looking for the value of 10, and oh, it's at position 7. Pop. If you've ever worked in the assembly language world, you'll remember having to push things onto the stack and pop them off of the stack. Well, it works almost the same way here. When I do an a.pop, what I get is the last value that's on my list. And now when I look at my list, it no longer contains that value. It popped it off of it and returned it to me. So a good way to kind of append and pop, depending upon if you're trying to use a list as a stack. Now remove is going to allow me to do, basically I'm going to remove values from my list. So if I wanted to remove, let's say 20, I could do an a.remove and say 20. And now 20 no longer exists. So pretty easy. Reverse is going to send me the reverse of my list. A.reverse. Now notice here it didn't actually send it to me. It did it in place. So A now contains a reverse of the list that it used to have. So instead of being 1, 2, 3, 4, those now are on the end. So again, it just reversed the overall list. You could do it again, a.reverse, and again, it's just going to do it in place, and my list is back the way we found it. The last item that I want to talk about in this method, or of these methods, is sort. So if I do a help on a.sort, I've got some weird stuff on the inside of here. And these are basically the defaults that the sort is going to perform unless you tell it differently. And again, it also does it in place, just like the reverse did. So what are these defaults? So we've got CMP equals none. So I'll be honest, I have yet to find a use for using CMP. So offhand, I can't even tell you what it does. But key and reverse are kind of useful. Reverse, again, I don't use too much, but I tend to find myself using key, periodically, at least more often than any of the others. So what happens if I do an a.sort and I don't change anything? So what ends up happening is my integers up here show up first, and then my strings, and it has to do with the way that, again, Python interprets integers in comparison to the way that it interprets an actual string. So what happens if I don't want that kind of functionality? What if I want it to interpret these as strings so that I can compare them against these strings? Well, then I'm going to have to use that key value in there. So an a.sort key equals, and here I'm going to pass it some kind of function. I'm going to tell it this is what I want you to do on each element within the list as you begin your sort operations, right? So there's something called a lambda, and I often misspell it, but we'll call it lambda, and we'll perform a string conversion on X. So what this is saying is this is an inline function. This inline function gets passed some value, and in our case it'll get passed each element within our list. That element, let's say in this case the 1, will get passed into X, meaning the value of X will be 1. And so what are we going to do to that? Well, we're going to do a string conversion on X. And so what sort sees is not an integer of 1, but a string of 1. And the same thing for our 2. Instead of sort seeing the integer of 2, it will see a string of 2. So when we hit enter here, it does the sort, And let's look at it. So earlier, we have 1, 2, 3, 5, and 10. Now we've got 1, 1, 0, 2, 3, 4 as a string. Our 5 is all the way back here, our 5, and then our 4. All right, so notice what really moved. The 10 moved up, and then the 5 moved back. Okay, and this is because this is how the sort operation didn't look at it as as integers, meaning the 1, 0 is definitely way higher than 5 and 3 and 2. Instead, it said, well, it's a string. Those strings start with 1, 1, 0. Well, 2 as the first digit of this string is higher than 1 as a string. So again, 10 got moved up, and then 5 got moved all the way back because, again, the string of 5 is larger or is higher than the value of the string of 4. And so again, the inline function allows us to do some kind of work on each of these values prior to the sort. And so you might find that there are times where that becomes very useful. I can think of times where I've had a list of lists, and so there are certain elements within that list of lists. I want it to look at that when it does its actual sort. So what does that kind of look like? So if I did another A, well, let's do this one as B equals. We've got this, and inside of our list, we'll pass it another list, and this one is going to be 1, 0. And then our next element is going to be, let's say, a 2, 1. We'll do a comma, bam. We'll do a 3, comma. This time we'll do a -1. All right, so our list is actually a list of 3 lists. So the first element is a list of 1, 0. Our second element is 2, 1. And our third element is 3, -1. So if I wanted to sort this, and I just did an b.sort, it's a little confusing as to how it's actually going to function. So what did it do? It basically did it in the order that it is in. Probably because maybe, I'm going to guess it looked at this first element, something along those lines. What we could kind of check out, we could redo our list here, and let's see. Let's do a -1, 5. So B now contains this other list here. We'll do a b.sort. Check out B, and it did in fact look at this first element. So it moved -1, 5 all the way here to the front, and then 1, 2, 3. But what if I wanted to pay attention to the second element in the list? Well, that's a little bit more difficult. So let's try this out. I'll probably screw it up a couple of times, but let's try it out. So b.sort, we'll do a key equals, I'll do a lambda x, and we'll do an x of 1. So what this is each of the elements that gets passed is going to be each of the lists. So x the first time through is going to be -1, 5, right? And then it's going to try 1, 0, and then 2, 1, so on and so forth. And then this bracket here is selecting the index value 1. So remember, we always start at 0. So what's going to be compared is the 5, the 0, the 1, and the -1. So what we expect to see is 3, -1, 1 0, 2 1, followed by -1 5. If everything works correctly, that's what we'll get. And in fact, that is what we get. So 3 -1. So no longer are we comparing these first values, we're comparing the second value. And so in that, I've found the lambda to be useful, and definitely that key value to be useful, because again, you might have lists of lists, you might have some weird kind of elements in there, and there's specific things that you want to be compared during the sort operation and other things you don't care about. So in our case, we cared about this second element, which is index value of 1. And so it used those when it compared instead of just the normal default first thing it finds, right? So pretty cool. That was lists, that was sorting, that was lambdas, and you conquered it. So moving on, we'll do a little bit of slicing. I'm not going to hit on it too hard. So we go back to our A, and earlier when we did strings, we were able to reverse their order by putting a -1. We can do the same thing. We can also specify a starting index and an ending index. So in our case, we're going to do a 2 3. So we expect to get a singular value back, which we do, and that's because this is 0 1 2. So we start here. 3 is the next element, but remember, this stop is exclusive, it's not inclusive. So we stop right as we're getting there, and so we only return 2. Okay, so those are slices, just like you could do with strings. You can also do them with lists. Now, when we were talking about strings, we also discussed joins. So we had this str.join, and we found that you have to pass it an iterable, and we discussed that a list is in fact an iterable. And so what it's going to do is take this string and join it to each of the items within the iterable. So let's see, what do we have? We have an A and we have a B. So let's create a C, and it's going to be a couple of words for us. It's going to be 1, 2, and pizza. Why? Because I'm hungry. So C is now equal to 1, 2, and pizza. What if we, I don't know, we're saving our values at some point, and we were going to put them in some type of comma-separated text file? So a pretty common method for doing it. So we need a way of taking each of the elements within our list, putting them in a comma-separated kind of value. So what we can do is build a string. That string contains the comma, and we'll do a dot join, and we'll pass it our list. And so what we get back is our list, comma separated, right? So if I had a long list and I was going to output that to some type of text file, and again I wanted that text file to be comma separated, perfect way to do it. All right, and there are times where depending upon what I'm doing, these might be individual letters. And so let's say I had a list, and this list just contained individual letters, so A, B, C. Right? So nothing terribly complicated there. It contains the letter A, the letter B, and the letter C. I can do a dot join on that as well, and I can pass it D. And so what I end up with is ABC, because I didn't specify anything in here. And so when I did my dot join, there was nothing to put in between it, so I end up with ABC. So I find myself doing that quite a bit, depending upon, hey, I'm breaking apart a word, doing something weird to some of the letters, and then putting them back together. And so the join, just like that, comes comes in pretty handy. Okay, so that's pretty much it. We've covered creating lists. There is other methods for creating lists, like we can, let's say, if we wanted to create a list that had a bunch of the same item. I'm not 100% sure why you would want to do that, but let's just say you did. Let's say you wanted a list that contained the letter A, and you wanted a list that contained 10 of those. So when we look at E now, it created 10 elements of A. So 1, 2, 3, 4, and so on and so forth. So if I do a len on E, I get 10 because I created 10 A's. So oftentimes you might see that. Again, I don't find it terribly useful to do so. I'm typically building my lists like that because I know what I want to put into them. Or I'm creating an empty list, EF, I'm creating an empty list, and then as my program works, it's just doing appends to that list, right? So I end up with elements that way, because I may not know exactly ahead of time what's going to end up in that list. So again, I'm relying on the fact that there are appends in my program, and some value then is going to get appended to the list. So that's lists for you. Hope you learned something. Hope you got something out of it. Hope I didn't blow your mind with some of the lambdas, but they are useful from time to time. So we will keep moving on. We should be tackling some other data types here in the near future. So thanks for watching.